Day 6. So the goals for today are more practice with p-values and the standardized scores, and to learn about two-sided testing. Now, you're like, oh my gosh, this packet looks long. Here's the thing. Example 1, I want you to take the time and work yourself. I will post a solution to it, but this is kind of pulling a lot of what we've done together in one place. It doesn't have absolutely everything. You notice it doesn't talk about identifying the variable and the research question, things like that, but it's a really good example. The one hint I will give as you start is you're going to notice that when you have pi, it's not going to be 0.5, just this is a hint. All right, because there are 3 options. So give this a try. We are going to, this pulls, like I said, a lot of good things together. So the solution should be posted a little bit later. Take a moment and jump down to page 39 of the notes, example 2. This is something we have not dealt with at all. These are called two-sided tests. And we're going to work through one just to make sure we understand what's going on with this. So the example is talking about trick-or-treating. So there's concern over weight going up, and researchers want to investigate whether children might be as tempted by candy as by toys for Halloween treats. So they tested households in 5 Connecticut neighborhoods, and they offered children 2 plates, one with lollipops or fruit candy, and one containing small, inexpensive Halloween toys, like a plastic bug that glows in the dark. One thing they don't talk about here is they didn't always put the fruit on the right-hand side or the left. They switched which side it was, so if kids were always just naturally grabbing for the right side, that was accounted for. So the researchers observed the selections of 283 trick-or-treaters between the ages of 3 and 14. Of the 283 kids in the study, 148 chose candy. And we want to see if that's meaningful. Does that tell us something? So based on the information above, we're going to answer the questions below. Now, does it specifically say, when you look at the research question, it says they're offered 2 things, and they don't, you may be tempted to say, well, they're looking to see if they actually want the toy more than candy. Actually, they're looking to see if there's a difference. So they don't say clearly we want to see if there's a much higher, or if there's a higher rate of the kids taking candy over the toys. They don't talk about it. They're looking to see if it's different. Now, personally, on a side note, lollipops or fruit candy or a small inexpensive Halloween toy. I don't know if you guys remember Halloween, but for me, it would really depend on the candy, and it would really depend on the toy. So I'm just saying, and it doesn't sound like great options all the way around to me. So let's go and look at the null hypothesis and get that set up. So the first question says, let pi denote the long-run probability of a child choosing candy. And we happen to have the numbers for candy. Could we have choosing toy instead? Sure, we would just have to do the 283 minus the 148, and that would tell you the number of children who chose the toy. First of all, we want to write in words, then with symbols, the null hypothesis and the alternate hypothesis. Note that the researchers are looking for preference, but it's not clear whether they're looking for preference of candy or for toy. So they would need to be very clear in their research question. You think, well, they're talking about obesity, so obviously they're talking, well, no, they just want to see if there's a difference, all right? So whether there's a preference for, they didn't say specifically preference for candy or toy, they just want to see if there's a difference. So the first thing I did is I took a moment, I paused this, and I wrote down my null and alternate hypothesis in words. So no symbols yet, just words. So the null hypothesis is just that candy and the toys are equally likely to be chosen. So when I write that in symbols, remember H sub 0, this is assuming nothing interesting is happening. This is my null hypothesis. So the long-run probability is going to be, looking at 2 things. So it's 50-50. If they randomly choose either a candy or a toy. On the other hand, the alternate hypothesis is we once again have to use the same number. That's something to keep in mind here. But now we need to think about the symbol. Candy and toy are not equally likely to be chosen. Now, once again, the research question did not specifically state any preference of one over the other, so we're just seeing if it's different. So, okay, why, looking down here, why not equal to? Well, we have no prior conjecture about whether the probability of picking candy is smaller or larger than the hypothesized value, in other words, 50-50 here, as stated in the null hypothesis. We're going to use a two-sided alternate hypothesis. So what is the observed, of course, so now we've written that out. We're going to continue on like we normally do. What's the observed proportion of times candy was picked, and which symbol should we be used to represent this value? Hopefully at this point in the quarter, you're already saying, okay, well, we're looking at the sample, so we're going to be looking at our p-hat, our proportion that we chose, the number of times we chose candy over the total sample size, and that gives us 0.523. Pi, remember, pi is talking about the whole population, all right? It's not talking about the proportion, which is related to the sample. To assess the plausibility of the researcher's results happen due to random chance alone, we need to simulate what kind of results could have happened by random chance alone, that is, if children were just randomly choosing between candies and toys. So below are these are my one proportion applet results. So I ran the one proportion applet and I filled it in as normal. Probability of heads is 0.5 because 50-50. We did 283 tosses. Now we want to do 283 tosses a lot of times to generate this null distribution. Initially, when I filled it in, honestly, what I did is it's, of course, initially, hopefully you've been doing this, it said number of heads, and I put in 148. But then I clicked proportion, and up popped the 0.523. Now, could I just have clicked proportion of heads and put in the 0.523 automatically? Sure. So the thing that's different from what we've done so far is right here. We know that it's not equal to, so it's two-sided. So you need to click that box and then out comes the result. Now this 0.4960, that's our p-value. So it counted both sides. There were 246 down here, red dots, so that were below, and then there were 250 that were above. You notice I did not have to make this calculation here. It does that all for you automatically, so you don't have to figure out what my lower value would be. But what you're going to want to notice is that we're looking at observations. Usually we did the greater than, we looked at one side. But when we're looking at a two-sided, in other words, not equal to, we have to look at what's happening on both sides to get to our p-value. So there's our p-value. You'll notice that we don't see the mean or the standard deviation. What did I not click here? Anybody can think about? In class, of course, I'd be asking this. I didn't click summary statistics. So if I had clicked that box, what did come up was the mean was actually 0.50 and the standard deviation was 0.031. So when you do this, it's always good to click that box. I did not click it because I wanted to show you what it looked like separately. Now remember, at Cal Poly, we love to learn by doing. So take advantage of the applets, play with them. It'll help you really get a sense for how this is really working. So I used, like I said, that one proportion applet to generate this null distribution. So this is just what if it happened if it was by random chance. And based on the information above, I want to state a conclusion. So I wrote out the p-value of 0.496, very large p-value. Look at the number of dots, it's a lot. That could you could easily randomly just choose one of these. It provides no evidence to say that candy and toy are not equally likely to be chosen. So there's no support for the alternate hypothesis. So it is plausible that candy and toy are equally preferred. Can we take, based on this one study, this one small study, that we can now generalize to the whole population that it doesn't matter, candy or toy, they're going to choose either one? No. This is one small study. We're not going to make general observations overall, or general conclusions, excuse me, to say that, oh yes, it doesn't really matter. Obviously this in fact intrigues me and thinks, was it because they chose some bad candy, or is it because the toys were really lousy, or is it because the kids couldn't see the things? There are I have questions, and I think it's an interesting thing and could be further studied. To wrap up this section though, in each of the three scenarios below, A, B, and C, the proportion of the dots circled in each dot plot below depict the corresponding p-values. So scenario A, this is a little hard to read, I apologize. H sub A, pi is less than whatever the number is. And you're going to see that down in this tail. We've done everything so far as greater than. This is the greater than. And this is where we've been mostly looking. And this remembers with the alternate hypothesis, you're going to notice that H sub 0 is always staying the same, pi equals whatever the number is. Now with the two-sided, the not equal, you have to look at both tails. So would you say that in general, roughly, the p-value in scenario C, where they're not equal to, is going to be roughly double? Yeah, that's pretty much what you'll find happens as you're going through homeworks. So note that when H sub A, the alternate hypothesis, is two-sided, the p-value is about twice as big compared to when the alternate hypothesis is one-sided, either being less than or greater than. So please take the time. I'm going to post the solution to the first problem, the first example, but make sure you give it a solid shot on your own before you look at the solutions.